All right, so here we are talking about the first section of probability, which should be the easy stuff for right now. Let's look at our basic scenario. Very classic example here where you take a die and you roll it and you figure out what is the chance of rolling a specific number on that die. So there's 6 numbers on a die, so 1 through 6. The chances of rolling a 3 would be 1 out of 6, right? Because there's only 1 3 on the die. So if we take that simple example that we all understand, we can kind of come up with a definition of probability. That if you want to figure out the probability that an event can occur, you're going to figure out all the ways that that event can occur out of the total possible equally likely outcomes of a sample space. So our M in this case was there was only 1 3, and our 6, that was the total number of equally likely outcomes, which there were 6 numbers on our die. Okay, so M out of N possible equally likely outcomes. All right, so let's put this to practice. Another example. Like I said, they like to use cards. What's the probability of drawing a heart from the standard deck of cards? So if you recall, our standard deck has 52 cards in it. We're not going to play with the jokers. And there are 4 suits, one of which being the hearts. In each suit, there's 13 cards. So that means that there's 13 hearts in this deck of cards. So there's 13 possible hearts that we could choose from out of a total of 52 cards that we could have chosen. So our probability of drawing a heart is going to be the 13 out of 52, which reduces down to 1 out of 4. And some people like to put it as a percentage, and you can. That's totally fine. So that would be a 25% chance. Okay, so here's an interesting fact. The probability of any event is going to be a number between 0 and 1. So if an event cannot occur at all, there's no way that it can happen, that probability is going to be a 0. And if the event is certain to occur, it's no doubt about it, it will occur, then the probability is 1. And if you like to use percentages, then it's between a 0% and a 100% chance. Okay, so that's interesting. All right, let's go a little bit more complex here. Suppose we now drew 2 cards. We're going to draw these at the same time. We're not going to draw one, put it back, and have the potential of drawing it again. So suppose we drew 2 cards from a well-shuffled deck of 52 cards without replacement. What is the probability that both of them are spades? Okay, well, let's think about that. We had to figure out all the different ways that we could have 2 spades together, right? So we have 13 of the cards in this deck that are spades. So the number M ways of drawing 2 spades is going to be 13 choose 2. So those are all the combinations of 2 spades together. That's going to be the number that goes on top. Those are all the possibilities that we want to have happen. Okay? The next thing we have to do is figure out N, the number that goes on the bottom. And so we're choosing 2 cards from a deck of 52. So there's the potential of choosing, say, a diamond and a club, right? So we have to have all those different combinations of 2 cards. So that's going to be the 52 choose 2. So once we have these 2 numbers, our M and our N, our probability is just to write the M divided by the N. So the ways of getting 2 spades over the ways of getting just 2 cards. And so you can calculate your combinations, which are 72 and 1,326, and you can reduce that to 1 out of 17 or 5.88% chance. Okay, so we practiced all of our combinations in order to be able to do our probability. All right? So you're going to probably do a lot of these types of questions. Very typical. All right, let's take a look at another type of probability. What is the probability of getting an 8 on a roll of a pair of dice? So now we have 2 dice that we're going to roll instead of just 1. So this increases the number of sums that we could get. So first of all, we have to figure out how many different possible outcomes are there. So since each dice has 6 possible outcomes, using our counting principle, 6 times 6, we get 36 possible outcomes for the pair when we roll them. So going back to this 8, how many ways are there of getting a total of 8? Well, we have to think about this because we're actually adding the numbers together, and there's only certain numbers on the dice that we could add together to make 8. So let's list them out. You've got 2 and 6, or 6 and 2. You have 3 and 5, or 5 and 3. And we have 4 and 4. And the reason why we separate these two as two different possibilities is because this is dice 1, this is die 2. Okay, but when we have 4, who's to say which one is die 1, die 2? It's going to be the same outcome. They're both 4s. So we don't do 4 and 4 again. Does that make sense? Hopefully. Okay, so we count this up. There's 5 possible ways of getting 8. So our probability is going to be 5 out of 36, or 13.89% chance. Okay, one last thing. This will be very useful. This is the complement theorem. That says let E be an event in a sample space, and we want to figure out the probability of that event E not occurring. So we don't want the probability of E, we want the probability of not E. So that formula is given as 1 minus the probability that the event will occur, or the probability of E. So it goes back to that idea that your probability is somewhere between 0 and 1. So if you have a probability of event happening, then 1 minus that probability is the event that it's not going to happen. So let's apply this. The probability of rolling a sum of 5 with a pair of dice is 1 out of 9. Find the probability of not rolling a sum of 5. So here's our E. We want not E, the probability of not E. So let's take a look. Using our formula, you would do 1 minus 1 over 9, which is going to be 8 out of 9. Now you could have done this the long way and figured out all the different ways to add up dice that do not make 5, add that all up, and put it out of 36. And as you can see, that would be 32 different things that you're going to have to count up or figure out before you could do this. This is a much faster way of doing our probability. Okay, so that's enough to get you on your way to first start out your probability problems. We'll look at the harder stuff later. Hope that was okay.